Um, Today we're going to be learning a little bit about big data. Just a small introduction, then look at a little bit of the architecture and why big data came into play in the first place and how it is useful in the industry today. That's what we're going to be broadly covering. A little bit about big data and the architecture and its components. Now, data has been around from a long time, but in the recent decade or so, there has been a massive explosion in the amount of data which is coming in. Because of the vast number of sources which have increased, because of the population growth, because of countries taking to digitization, and so on and so forth. There are many such reasons. So as in, when the amount of data keeps increasing, the processing of the data becomes difficult, the storage is an issue, and all your other operations become dependent on how storage and processing take place. So the term big data came into the picture because of these, complex data sets, because of the vast amount of data which, today is coming into the world, and a system was required in order to manage this boom in data, which is where big data systems came into place. So, some of the traditional challenges earlier, like storage, transformation of data, curation, search, and so on, were a big problem when data became more real time. Data kept coming in huge amounts. So big data helps alleviate some of these problems to a certain extent. And we look at how it helps do that. So big data in general is categorized or classified based on the three V's, as we call it, sometimes four. Um, Based on which we say that this is big data, or the amount of data which is coming in is huge and hence it's big data. So let's look at what those three are. So the first one is volume, or the scale of the data, as we call it. Now, as I had explained earlier, the amount of data, or the scale of data, has grown exponentially over the past couple of decades, and it would continue to grow in that manner over the next 2 decades or so as well, because systems are getting digitized. The number of organizations collecting data have increased exponentially. The number of people who are contributing to the data have also increased because of use of mobile devices and so on and so forth. And it is expected that there would be about 35 zettabytes of data in the next few years, which would be collected, which is a huge amount of data coming in. And this will continue to grow, which requires you to have a system to be able to manage that. Um, the second thing is obviously the uh, different source of data, or the complexity and the variety of data which is coming into play. Uh, Along with traditional relational data, which used to come from tables, legacy systems, and so on, today you have many different forms of data, like text, uh, semi-structured data, which is a combination of, say, tables and images and text, graph data from social networks, real-time streaming data from different sensors, from people using the mobiles. I mean, we all run today with our Apple Watches, and all this data is streamed into a central system which needs to cater to this real time. And obviously, big applications like search applications, booking applications, big public data available online. All this is contributing to a vast variety of different sources and different kinds of data which need to be processed, managed, stored, transformed, you name it, all the traditional operations. And the third one is definitely the velocity or the speed of the data. And this has been one of the major changes, or the major transformations over the past few years. Um, Today, data is being generated at an unbelievable pace. It needs to be processed as and when it comes in. And in order to do that, you need to have systems capable enough to be able to process that amount of data. And, you know, for any organization, if you miss processing something and you take a decision late, it's a lot of loss for the organization, which is why all these decisions need to be taken as quickly as possible. Things like promotions on e-commerce websites. You all go to Amazon today and you see, since you're purchasing this, you can bundle it with this. You can also purchase these other items. Now, all these are calculated real time on the fly based on your trend and purchase patterns. And obviously, in the healthcare industry, and as you can see here, it's imperative that things be real time because monitoring patients' heart rates, monitoring different metrics, and from different sensors of patient is all very critical to the life of patient, which is why it is important. Now, how has the model changed? From traditional models to current models in terms of data. So earlier on, there were few companies who used to generate data, and people used to just consume and use that data. Right? There was nothing else which was happening. But today, the model is very different. There are companies and us and the people, everyone is generating data, and all of us are consuming the data which is being generated by the different sources. So it's now become, we are generating everything, we are also consuming everything, which is why we need systems which are capable of handling this current model. Unlike traditional systems, which you needed just a single storage repository and people were just accessing that repository and using it. It's not that way today. So what is driving big data, right? Very, very big question. As businesses start scaling, they would obviously want more value to be extracted out of their businesses because over the past 20-30 years they have been collecting data, working with customers, working with different people, and now they want to use that data to drive business. So unlike traditional BI earlier, wherein you just had reporting and dashboards, things now have moved more into a predictive analytics and decision making stage, which increases the complexity of the operations itself, along with adding more business value. So all of these things, which include complex analysis, huge data sets, real-time predictions, um, and not only querying of data, require you to have systems which can um, be able to store and process this, which is what is a major driving factor for big data. So businesses wanting to gain insights from their data, add to the business value, is the major driving factor. And you can see that these are some of the different areas in the predictive analytics and data mining space, which is driving that. Now, with big data, obviously comes big data analytics, which is the process of basically analyzing complex data coming in real time, and uncovering information and insights from all of this data, and which would help drive business decisions and add business value. Now, as we were talking about earlier, um, traditional BI versus big data analytics, things have moved more from people and organizations just generating reports and analysis to what will happen in the future. Can I use data science and predictive analytics to help me with that? Um, Things have moved away from structured data sets, fixed amount of data sets, to large scale data sets, more unstructured in nature, data coming in from different sources, more complex data models. And what has this led to? Unlike traditional, the traditional approach, sorry, which said, I just want to know what happened and why that happened by looking at the data. Today, we want to know more about um, what are the insights, what can we do with the data, what are the correlation between different things, and so on, which makes this thing more complex. It makes it more difficult. The processing required is much more, and hence big data analytics is the way to go, and like for organizations, unlike simple traditional BI. Now, big data in itself is a big term, and the landscape involves a lot of different areas, a lot of different tools, right from operational infrastructure, to cloud infrastructure, infrastructure as a service. Big names like Microsoft Azure, Amazon Web Services, to different BI tools like Tableau, Oracle, and so on. Coupled with technologies like Hadoop and Spark is what is disrupting the ecosystem today, and we learn about all of this as we go ahead. So you don't need to be skeptical about what these terms means at the moment, but all of these are different tools and resources which help or which fall into the big data ecosystem, which help make big data and analytics possible in this space. Now, let us look at a little bit on the big data architecture side. Do we have any questions till now in terms of the introduction of big data? Okay, so why do we need this architecture? That's the important question. Now, if you see this graph here, and if you look at the past 2 decades or so, what has generally happened is that your processing capability in terms of performance has increased to quite an extent. But the capability of memory to keep up with the processing has not reached it yet, and it's significantly far. So the rate at which memory performance has increased has been significantly lower than that of processing. Now, because of this, in traditional systems, there is a difficulty for memory to keep up with the processing power and capability, because you cannot read write as fast as you can process the data. And because of this major gap here, even in the recent decade, and which this has kind of plateaued out over the past 10 years, but it's going to increase soon. This is the reason why big data, the architecture, comes into play in the first place. So what is different in the architecture, right? So the difference in the architecture, unlike traditional systems, is that the big data architecture treats memory and processing different, and has different management frameworks in order to ensure that the gap between memory and processing, as you see here, is not transparent, but made more efficient using different technologies and different tools. Now, the traditional big data architecture has multiple layers, multiple tools involved, right from different data sources, as you see here on the left, to ingesting it into the main, the main body or the main system, to having different management tools like MapReduce for processing, Hive and Scoop for ingestion and storage, to different analytics and visualization layers. And all of these, in one way or the other, contribute towards making the ecosystem efficient, more robust, fast, and that is what is required today, because of the kind of data which is coming in. In the further classes, in the further workshops which will happen, you will learn more about each of these in more detail. But what we'll do now is, all of you have heard this term Hadoop from different places, and you must all be curious to know about what it is. So let me just start you off with a brief definition, a brief insight into what it is, and then the next class onwards, we'll move towards all of them in more detail. So what is Hadoop, right? So Hadoop is basically a distributed open source framework which helps make processing and storage more efficient. Now, what are some of the advantages which come to mind? The number one, as I said, for rapidly growing data sets, it helps with storage and processing very efficiently. It's very easily scalable, and it has very high availability, meaning if one element of your data storage goes down, your data is available from another area, and you don't lose the data, it's still accessible. Then it uses commodity hardware, so very less redundancy in terms of how data is being stored. It's fault tolerant, so since it's a distributed framework, faults at one place can does not affect the entire system. And it also packs a lot of processing power, does not concentrate completely on data only. So since it's decoupled, it proves to be more efficient. And Hadoop has two main components basically. One is your storage component, the other is your processing component. So the storage component is called Hadoop Distributed File System, or HDFS for short. It's a high bandwidth clustered storage, reliable distributed file system for large files. So think of it as you having a bookshelf and you have multiple racks on the bookshelf, and you have one book in multiple racks. So you have a copy of the books, and if you lose one, you still have another one in the other rack. So the distributed file system works in a similar fashion, but obviously does it more efficiently. And MapReduce is basically a technique or a processing capability of the big data ecosystem, or it's a tool which uh, essentially is used to process large amounts of data from the HDFS uh, very efficiently. And we learn about this in more detail later. So, and what are some of the main applications? Well, uh, Hadoop has been is as a base is being used a lot in the advertising space in order to generate recommendations, to do behavior analysis, and so on. It's used in a lot of searches, like your traditional Bing, Google searches, where you have a lot of documents and images being retrieved, and also for security in terms of uncovering different patterns and so on and so forth. But what are some of the challenges, right? We saw some of the advantages of having big data, of having Hadoop, of having the ecosystem as a whole. But there are still some challenges. The two main ones basically are that the bottleneck today is in the technology, right? All this is new architecture, all this is new algorithms, new techniques, but organizations are not completely ready to adopt that yet because they don't have the data systems correct. Their legacy systems are, they're too broad, they're too unclean, they're not very structured, and also they're not ready to embark on that journey. So the technology is a bottleneck in that sense. But today, nowadays, with the cloud becoming more prominent, people are curbing that bottleneck as well. And also, number two is, in terms of the skills itself, big data is not a common skill among people, and it's a very niche skill to learn. And hence, there are not a lot of people aware of the different big data technologies out there, which is another bottleneck because in terms when it comes to development and implementation of the big data ecosystem itself. What are some of the benefits? Real-time data, as we talked about, is is that which comes in at a considerably high pace, and the big data ecosystem makes analyzing this and processing this very seamless and efficient. Um, Hadoop kind of technologies, they provide you the scalability and flexibility of storage and processing. And also, technologies like MapReduce and Hive, they allow you to run queries and search algorithms without manipulating data too much, because uh, the big data storage ecosystem handles data in a very efficient manner. So what did we learn today? We basically did understand a little bit about what big data is, what are the three V's, why is it called big data, what are some of the applications, the benefits of having the ecosystem, and what is the traditional architecture of the big data ecosystem, and a brief introduction to Hadoop. Uh, if you have any questions, do reach out to me, and I'll be happy to answer them for you. In the next session, we'll actually take up all of these in more detail. We look at the components, how they are used, how you can actually use the different components to create a big data system, and so on. Thank you.